The speed and flight pattern of a remote-controlled model airplane are determined by the joystick positions of a radio controller. Based on the position of the joystick, the controller emits radio wave activity at regular time intervals lasting for a specific length of time. These radio wave pulses are transmitted to a receiver in the plane and converted from analog to digital pulses. These digital pulses are delivered to a servo motor, instructing it to hold a particular throttle or flap position. The width or duration of the pulses will vary based on the position of the joystick. The control pulses only last a few milliseconds and repeat about 50 times per second. A specific series of impulse signals will hold the servo horn in a fixed position. Let's look at the operation of a servo motor in more detail. The horn of a servo motor can be activated to hold certain positions. This position is set by the length of a radio pulse arriving from the radio controller. The servo expects to receive a converted digital pulse roughly every 20 milliseconds. This train of pulses instructs the servo motor to hold its position. It is the pulse duration repeating at regular intervals that tells the servo where to turn. For example, if the pulse is high for 1 millisecond, then the servo horn position can be programmed to be at 0 degrees. If it is 1.5 milliseconds, it is set to the center or 90-degree position. If the pulse signal is 2 milliseconds, then it can be instructed to go to the 180-degree position. The servo motor can be programmed to hold positions at any range of angles necessary to provide the precise control required to adjust the flaps. Varying the pulse width is all that is required to determine the position the servo motor will maintain.